Do you have a good number now? Can we start?
I'm ready when you want.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuh, and good evening, everyone. On behalf of the Dhahran Geoscience Society, I would like to welcome you all to the DGS webinar, Artificial Intelligence, Risks and Opportunities, with Professor Saud Almuhaidib. This is Saud al-Shihri. I'm the Vice President for the Professional Development, and it is my pleasure to be the moderator for tonight's webinar. Before we start our webinar, we would like to take this opportunity to thank our sponsors for their great support to DGS. Please note, we will answer your questions after the presentations. So please write your questions in the Q&A session so we can address them after the presentation to Professor Saud Almuhaidib. And now allow me to introduce our guest speaker, Professor Saud Almuhaidib. But first, let me bring your attention to a summary of his biography. Dr. Saud Almuhaidib obtained a bachelor's degree in computer science with honors in 1980 from Nova University in Florida. He then joined Saudi Aramco for 5 years. Later, he continued his postgraduate studies and obtained a master's degree with distinction in computer science from KFUPM, followed by a diploma in education from King Faisal University. In 2002, Dr. Almuhaidib earned his doctorate with excellence in artificial intelligence from Leeds University. Dr. Almuhaidib has headed and led multiple positions in different sectors, such as Saudi education curricula, the National Curriculum Development Committee, and the Girls' College in Eastern Province. In 2017, he established the first robot academy in the Middle East, which is located in the Khobar city now. Welcome, Professor Saud Almuhaidib, and we are pleased to have you tonight. The floor is yours.
Assalamu alaikum wa rahmatullah. I'm going to join screen. This will, okay.
Yeah, go ahead. You can share the screen now.
Okay. Bismillah, alhamdulillah, Rasulullah. I am Saud Almuhaidib, and I am very pleased to be with you. And I thank Dhahran Geo Society for inviting me to give this presentation. I will go fast on what is artificial intelligence and how can we build intelligence in the machine. Then we'll find together the threats and the opportunities that might be in the future from the artificial intelligence. So first, I'll give you a story of family. This Saleh and his wife went to a picnic. Saleh said, Ahmed is very smart. So Ghada said, so is our son Badr. He's also smart. So they asked them, well, Saleh, Ahmed and Badr, go get us good orange. So they got these oranges. So Dad asked Ahmed, why did you get this orange? It's not yet, it's green. So he said, yesterday, when you asked me to bring you a pen, I brought you the yellow pen, and you said, no, the green pen is the good one. So Ahmed thought green is good. That's assuming he has no knowledge before. So we'll give this example, simple examples. So we'll try to see how knowledge is built. So while Badr, he had different experience where he thought yellow is good. And that's why he brought the orange or yellow orange. So what happened? Well, Ahmed thought green pen is good. So he thought also good orange is green. But he found it's bad because they told him it's not good. So he now learned that for orange, good is yellow, while for pen, good is green. And this tree starts building in the mind of a human being. let's see what Bedr, what happened to Bedr. Bedr thought yellow is good. So after this experience, there was an enforcement that yellow is good. Who learned? Of course, Ahmed learned, and Bedr, learned a misleading learning. Let's see what happens next. This tree starts building. It becomes like more branches and vertices. These are what we call nodes or vertices, and these are the edges or links between the nodes. And the tree starts building as we go on. As the tree gets bigger, the nodes and the relations makes meanings. So the meanings that we have of things, objects, behaviors, and anything is because of these links between the nodes and the edges in our mind. That's how we try to simplify how knowledge is built. The tree gets bigger and bigger with time. But look, what if we have a misleading information? Let's see this. Father said, "How is your new teacher, son?" "He's the best teacher ever." "Oh, I want to give him a gift. But what is so good about him?" So I would write it on the gift. What is so good about him? He doesn't teach. He lets us play and go to sleep. So for son, a good teacher who doesn't give them homework. So this is what we call a misleading data. What if this data comes in the tree? Will we make wrong decisions in the when we want to make a decision in our life? There's a lot of misleading information that we get from the environment, and the media, and from people. So how things are going to build up. Look at what I'm going to show you now. This is a simple tree. An orange can be green, yellow, or red. But with time, we will find that the connection between the vertex, this vertex, and the yellow gets thicker with time. So we represent it in math with density. So this, for example, comes with time 60, while this is 10 and 4 and so on. And as experience grows, this number becomes 1,000, while this becomes 100, or 100,000 and 100. But sometimes orange is green at the beginning of, when it's in the tree. And when is that happening? That's you can think of that with a bigger tree with other branches that can lead to orange to become green. Look at this big tree. The tree in our mind will be something like this or even bigger. And that's the tree that we want to build in the system. So the machine will try to find out what do we mean by the words that we talk, or the things that we do, or the behaviors that we make. Let's take an English lesson. What is this? How do you read this? Is it this? Is it tear? Or is it tear? Why did you read it here, tear? A tear rolled down his cheek as he watched his father tear up his favorite photo. Why did you read it here, tear? Why you read it in the other one, tear? It's the context. Well, if we can tell how a person can distinguish between the two and model it and try to find a mathematical representation of that, then we can make the machine distinguish between the two. Let's take another word. What is this? Is it object? This is an object here. Or is it object? Refuse. And the same case as the before. Is it dog? Is it this? Or is it past tense of dive? Lead group? Or is it led? I ask him to lead the group, or he's exposed to lead, or is it the lead of a pencil? How do you know which one? How do the machine recognize the meaning that you want to pass through a statement? Is it this? Desert? Or is it dessert? I don't mean this dessert, because this is spelled like this. I mean dessert, like I'm not going to desert you. I'm not going to leave you alone. I'm not going to leave you and go forever. So how do we read it? And why dessert sometimes spelled like this and sometimes spelled like this, to give two meanings, the same sound? And what about this? Is it this? Or is it that? What about the sound? When it comes to sound, is it this one? So to have the machine communicate with us, knowing all this complexity of combining these words, if we program it the way we usually do in logic, if then else, we'll take a lifetime of a person to program it, because there's trillions of possibilities. So we can't do that, and it will consume a lot of computer time to solve thing and answer your question. So what do we do to do that? Whether to communicate with people in words, or to understand the behaviors, or anything else. Let's see what happens here. How do we make the machine learn? We want to make it learn just like the small kid learn. So look at this. Ahmed was in a paint shop with his mom and dad, and he heard his mom said, "I want orange." So he jumped to the next grocery store and he picked up an orange. His mom said, "What is this?" He said, "Orange. I heard you say I want orange." She said, "No, I was telling your dad I want orange." She means color orange. And I just stand there and say, well, this is liquid while this is fruit. And what is the same in both? So he decided the color is the same. So orange is not the fruit. Orange is the color. That's what he thought. So when it comes to fruit, orange comes to this, while in paint, it is like this. So he split the node into two. But one day they were in a farm, and the farmer told his father that this is an orange tree. I'm a jump. No, it's not orange. It's not orange color. How can it be orange? So then he understood that this orange is not yet to eat. It's not fresh yet. So now he's learning. And that's what happened in our minds. That's when a child comes to a cattle and touch the cattle and get burned, he learned. Or we tell him, no, it's hot, he also learns. And the tree builds more. Red is very close to orange and so on, and builds on. And then when we want to find meaning, we predict what is the meaning according to these lengths and according to the density. of these edges. And sometimes we have to calculate number of edges to come up on which route should we follow. That guides us to talk about the difference between the logic that we write programs with now and the knowledge tree. The way we do it in our in the past 10 years, we write logic like the if then else logic. While now we are turning to the knowledge tree where data builds up the information, and this information makes meanings, and it grows and accumulates, and the leaves grows and the branches grows as experience increases and accumulates. Well, how do we transfer this or make the machine become intelligent as the child becomes intelligent? Well, first we train the machine. And what do we mean by training the machine? We feed the machine a lot of data to find patterns, within the data. And these patterns are the rules that we're going to use to decide, the machine going to use to decide. So from all this data, it kind of builds up an experience. And this experience will guide the machine to become intelligent. And then it will use the patterns that it developed from the training to predict what should the decision be. And let's see. Okay, so how do we train it, or how do we? What are the styles of that? There's two types. We can either supervise the training of the machine. So what we mean by supervise is we give the data and we label it. We say this is a jacket, this is a cat, and this is, and we tell the machine what it is with a huge number of pictures or data, whatever type it is. Or we let it find by itself and search and build the tree just like we did earlier and find out the meanings out of the building up the information. When do we make a supervised and when we don't? What's the benefits of supervised AI and what's the cons of it? Supervised AI, we give it a model data, but that model data we select. So in a lot of times it's a bias. It's what we think it's model data. We have to free the data from our opinion to be really, real data. While unsupervised, it picks up the information and it builds the experience as it goes around and experience things, the machine experience things. Okay, well, why don't we use unsupervised? Because we just can't let a car, self-driving car, go to the street and drive without being trained before with a lot of data. It will make a lot of accidents and kill a lot of people before it is trained. So what we do is we train it with model data that we think is good, and then it becomes trained. So so it builds patterns and then decides what are the difference of these things. Let's look at this example. These are jackets, dresses, pants, yeah, t-shirts, kids dress, yeah. Better, yes, ma? Well, we going to your uncle's house, get dressed. What shall I wear? Put on your jeans and your nice shirt. Well, you mean, ma, you mean the blue one? No, that's not shirt. Well, I forgot to tell you that the machine should imitate better to be able to be as smart as a human being. Well, is it the blue shirt? Ma, no, you don't have blue shirt. That's a t-shirt. Oh, these are t-shirts. So which one, Ma? The one with the long sleeves. Oh, it's too hot today, Ma, to wear these things. No, these are jackets. Oh, so he labeled them jackets. So what is it, Ma? It's the white one with the long sleeves and high neck. Ah, okay, Ma. And he wears it. Can we make the machine imitate or mimic better? If we can make it, then it gets trained and it gets intelligent. We'll show some mathematical representation of what we're saying in a simple manner. Of course, it's simplified for the lecture purpose. Look at this. This is a real estate agent. He's very smart. You tell him how big a land you want, and he will tell you the price without even looking in the books. And if you tell him how much you have money, and then you tell you how big a land you can get. Well, let's see, how did he get to be that smart, and can we make it in a machine? First one he solved, he didn't build this graph. He built this graph in his mind, but let's see if we can put it as a graph. The first one he solved was 102 meters or 110 meters for 150,000 reals. Second one is for 100 meters for 105,000 reals. And with time, there is a pattern. Can we develop a pattern? Yes. Then, if we can feed the machine with a lot of data, and it can develop a pattern, and then use the pattern to determine an answer, then the machine would be as smart as this real estate agent. And not only this agent will be smart, everyone will be smart having this machine. Well, let's see, but sometimes it's not two-dimension, it's three-dimension. It's when there's more rooms, then you can, the prices change. And this smart guy can do it. But what if there's 3, 4 dimension? Have you ever thought of 4 dimension? Yes. What if there is a neighborhood? The neighborhood affects the price. What if the guarantees that made on the house, they affect the price? What if we have hundreds of features, which we call here dimensions? Will this real estate agent be able to manage? Will he know if we say one dimension is the countries, and the other dimension is the neighborhood, and the other dimension is the guarantees, and how good is the building design, and so on? So it will be a very complicated pattern that the machine can develop and find out the pattern, while it might be very hard to a person to find. Let's take another example, also a simple example, and see another way of looking at it. Before that, I want to comment here. In the past, we give data and we give rules, if then else, if this, do that, if this, do that, or patterns, and then we get results. And that's our normal logic programming. We give data and rules, and we get results. In AI, it's different. We give the machine the data, and we give it the results of the data, of a model data, like this pandemic that we have. We give it the data of a previous pandemic, and the results of the previous the pandemic, and it will find the rules and patterns, and it will say if this do that and if that do that. It will find the patterns and rules and give it to us so we can use it in the next pandemic, or it will recommend what should be done in the next pandemic. Let's take the next example. Let's see this plot. We have a lot of dots everywhere. How can we tell if these dots are kids or paper bag? Now we want to apply this to a car, for example, a self-driving car, and it's driving across a highway, but it wants to know whether these are kids crossing the street or it's a paper bag, because the decision will be different. So, or any other example, I'm just picking up the idea of a car and kid and a paper bag. Let's see, what we do is we take two dots anywhere, we put them anywhere. Don't ask me why did you put them here, because you put them anywhere, and then you connect between them and you draw a perpendicular line, and then you consider the dots here to be with the same color as this one, while the dots here to be red, supposing that these might be pictures of kids and these are pictures of paper bags or whatever. And but you don't know, you just fed the machine with a lot of pictures, and the machine wants to cluster them and make them in classes. But with this case, whatever comes here, when we see a dot comes here, it will be with this group, and whatever is here will be with this group. So if there's a dot here, it will be considered with this. So this is not a good line. So we keep. So what we do to draw a good. So what we do to cluster them in a good manner, what we do is we take this dot and we try to put it in the middle, and we take this dot, the red one, and we try to put it in the middle of this group. How do we do this? We calculate all the x's and all the y's, and then we kind of find out the mean and find where this should be, and we move it to that point, and we move this, and then we again draw a line, a dotted line between them, and a perpendicular line, and we keep doing this process until you can't move this dot anymore. It will be in the center of the thing, and no matter what you do, it's in this place. Whatever you calculate, it comes to the same dot. So we say this is a cluster, and this is another cluster. But what if we have more dots? What if we have, what if we want to have three clusters? Then we put third dot and we do the same process, and then we'll find that we come up with three clusters. This is a kid, this is a paper bag, and this is a ball. So when a dot comes here, then it's a ball. If we see one here, then it is a kid, and if we see one here, then it is a paper bag. But what if it's here? Well, then we have to go for third dimension, on fourth dimension, or fifth dimension. These are features, what we call features or dimensions, to give us a clearer picture of what the dot or what the object is. Let's go for another thing here. Suppose we have these clusters, and we want to know whether the dot, where is it, where does it belong to? And we have three clusters. We have a kid, paper bag, and a ball. And we want to know who this dot belongs to. So what we do is we give what we call a k nearest neighbor. So let's assume k is 3. We usually select odd numbers, because if we select even numbers, then if they're equal, then we might not be able to decide. So if, let's say it's 3, the 3 nearest will decide whether this is orange or blue. So the 3 nearest, it's orange. So if we take 5, we might be a little different. Okay, and so the different number will give us different results sometimes, and sometimes not. What about this? If we select 1, it's red, but if we select 3, it's blue, and if we select 5, it might change and change ever. So what we do is we go 3-dimension. When we go 3-dimension, we'll find something strange. This is the dot. It's not red. Well, when we looked from this direction, we thought it's red because it was a plane. But when we put it in 3-dimension, then then it's not red, it's not blue, and it's not orange. So we have to find the k nearest neighbor to decide whether it's blue or whatever. So it might be, it's most likely blue. But if we look from the top and we have it in plane, look at this. If we look at it, if we look from the top, it would be something like the blue and the orange will be top of each other, and this dot will not be anymore red. So there's a number of ways to for the machine to find out a new object or behavior or thing or picture. What is it and where does it belong? And then makes the decision accordingly. So let's take another one. So this, what we call a support vector machine. We have 2 clusters, and we try to draw a line boundary between them. So we decide everything in the left of the line will be blue, everything on the right of the line will be orange. But this is not good, because whatever is here will be blue. So we change the line. Same thing, it's not good. This will be blue and this will be orange. So we keep changing the line and find the distances between the dots, the nearest dots to it, until we find the best line between them. And then we kind of give us more room, to some boundaries and room, so we can tell, we are more sure that whatever here is orange and whatever is here is blue, and whatever in the middle, we can think of it and make more investigations like that. And if we go 3-dimension, we can draw not a line, but we can draw a plane, and then this here will be, we can put a box that will find the differences between the blue and the orange, and so on. And if we look at this from a different angle, if we look from the top on a plane to this, what will it look like? It will look like this. So that's why we go for more dimensions, to find out more about the behaviors or the things or objects or whatever. So what is AI? So what is AI? AI, we try to, when we feed the data to the machine, it will try to find the best patterns from all these algorithms, and a lot of more algorithms. Tries to find which algorithm is best and the model for the thing. So AI is making the machine able to learn from experience and recognize patterns, whether experience with time or with feeding data that is made of experience in the past. So making the machine able to learn from experience and recognize patterns and predict best reaction toward new events. So the machine, when predicts the patterns and recognize the patterns, it can, when it recognize the patterns of the previous data, then it can predict the best reactions to what it faces, new events. Um, this is going into almost everything. So we are moving to a no privacy era. In the past, when computers came into our lives, things changed and changed a lot. People rejected having computers at the beginning, and they insisted on keeping paperwork. But with time, everything changed, and everybody works with computers. Doctors today can't work without computers. Engineers can't work without computers. Teachers can't work without computers. Indeed, you have a computer in your pocket. It does everything for you. It does your accounting, it does your emails, and takes you to the place you want. So you can't live without a computer today. The coming future, the close coming future, we're gonna move to the artificial intelligence era, where artificial intelligence will be in everything, in every job, in every, you go to a restaurant, you won't find people, you'll find robot with intelligence that service you. You'll have this self-driving cars in the streets. It's already there in model streets, but in the near future, it's going to be even in the crowded cities, because we will get better predictions. Once we get better predictions for the car, then we can get it into the streets, in the crowded streets. So the next era is the artificial intelligence era. The artificial intelligence will be able to identify the phone calls, emails. It will understand everything in it. It will find the context and understand what is the meaning of the phone calls or even the emails. It's already doing that in a way, but it's going to be much better with time gone. Google now. Google in the past, you give it some words to search. Google engine, you give it some words to search, it gives you the articles that has the words that you specify. But today, if you give Google some words, it will give you sometimes articles that you didn't mention any, that doesn't have any of the words you mentioned. And the reason is, it understands from the context what you want to search for, and then it searches for you by what it thinks you want, not by what you wrote. And this will happen with everything, with human behavior. You will be with the robot just like you will be with a friend. It knows everything about you. Well, it's different. You know, robots are not artificial intelligence. Robots are mechanical things that are programmed. And artificial intelligence is a concept that you can build into robots. So this machine with artificial intelligence will understand your behavior and will know your behavior better than your friends, because with all the data in the world put in a cloud or in a position and illustrated by the machine, and the machine is trained on them, it will model these or patterns these, and it will find with time what pattern are you, or what is your behavior. Your behavior is close to which one of these, and then it will predict what will you do if something happens in front of you. And this is very dangerous, because this is very good and very dangerous, because if somebody knows how you will decide if you're exposed to certain events or acts, then you might be mastered. And that's why we say this ability should be distributed on all Earth. No one company should have the AI. It should be for everybody. So we should be aware of that as well. It gives us, you can tell what benefits. It will give us a lot of benefits because it knows exactly what we want. Not exactly, but to a certain extent, because it predicts. And as the data is a lot, then the prediction will be almost close to 100%. It could be 85, 90, 95% correct. So from what I told you before, the machine will be able to predict what is expected if it sees some hints. If there's some things happen in today's life, it will predict what might happen in the future, because it sees these hints and compare them to the models that it built from the data and decided that how to react about it. So it is an existential threat, not from the point of bombing or something like that. No, it's an existential threat from making us robots. We will be robots, and the machine will be the master, because when I wake up in the morning, I'll open my mobile, I'll start my mobile, and I will find that it tells me where to go for breakfast, because it's the best place where I really like it. Then I'll go there. Then it will tell me what I should do about certain things, and where do I go for vacation, and how do I do this and that. Just like we're doing now with Google Maps, we're going exactly in the ways that they tell us. We come to a point of trusting the Google Maps to 95% or more. So we started it and we just go, and it will be in every part of our life. So this is the threat that I see of the AI more than anything else, more than losing jobs or whatever, because normally science make some jobs vanishes and develops different jobs, just like the computers before. But the real threat is if we are changed to become robots and the machine becomes the master. But what should we do? If you look at the Red Flag Act of England, when they developed the cars, they said a car should not be in the street but with 3 guys in it. One driving, and one tell him what to do, and a third one in the street with a red flag telling the people to go away from the way of the vehicle. So but that like delayed the building of cars in England. So shall we stop research to protect human beings, or shall we destroy human being privacy to let science prevail? Well, thank you. I hope you enjoyed this lecture, and I hope I passed the message I decided I wanted to. Doctor, you have the microphone.
Thank you very much, Dr. Saud. It was a very informative presentation. Now we're going to take a couple of minutes as a floor for Q&A, and we have a couple of questions. We can address them now. So the first question is, how can we validate the algorithm we can use, and also how can we choose the scoring to validate?
Well, we're not gonna select the algorithm. The machine will select the best algorithm. It's we'll feed the data to the machine. Let me give an example. So suppose we have we have an earlier pandemic, and we want to see how we can benefit from the earlier pandemic in the today's pandemic. So what we do is we take all the data of the earlier pandemic and we feed it to the machine, and we take 80% of the or 70% or 80% of the earlier pandemic, and we feed it to the machine, and the machine will develop patterns. And then we'll use the 30% or 20% that we didn't use in developing to test the algorithms or the patterns that it developed. And if it comes to high accuracy, then the machine, the rules that it developed, which is the patterns, can be used in the future pandemic or the real life today's pandemic. This is how we develop, how the machine develops the rules. It kinds of try different algorithms until it picks up the algorithm that fits best and gives a higher accuracy.
Excellent. The next question will be, what are the different examples from industry that uses AI to predict solutions?
Well, Google Maps. Google Maps, suppose you're going out of your house and you want to go to the mall next, about 3 blocks from you. How many routes do you go through? There is thousands of routes. I asked my son one day, how many routes that takes you to the shopping center next to us? He said 1. I said, no, there's more. And he said 2. I said, what if we go, any street you go, there's you can turn right or left, and then the next one you can turn right or left, and the next one right or left. But in your mind, you predict the shorter path from fast calculation, and you selected the route. You'll find somebody else selected a little different route, and so on. The machine, to find that, it either makes all the calculations or predicts. And suppose you are going to a place a little further, 5 kilometers or 10 kilometers. How many routes are there to this place? Millions. And if there is millions of people using this this algorithm, can you calculate how much computer power we need to solve this equation? You can't. You must use AI and prediction. This is one of the applications. Another application is the Google Translator. The Google search now is using the AI. Another example is Siri. It listens to you. It kind of try to find out what did you say from putting each word by itself, and then try to find what do you mean by putting these words together and develop a meaning, and then from that meaning it gives you an answer. And when it can't do it, it gives you a joke.
Fair enough. Excellent. The next question that we have here is that what do you think will be the most significant developments in AI that will affect the oil and gas industry in the next decade?
Well, I worked in Aramco for 5 years, and I worked in XPEC, Exploration Petroleum Computer Center. And I know from that time, that was 80 to 85. I know from that time, there's a lot of data. And with AI, you can't work without a lot of data. You must have a lot of data to kind of make a prediction. And suppose we feed all this data to a machine to analyze and find out patterns of how. I'm not a petroleum engineer or geologist, but I will give an example, and you might adjust it to suit what you know better than me. So suppose you take all this data and put it to the machine, and the machine will find the patterns that you should decide. You don't decide. The machine will find the patterns that when you did this, the reaction was that, and when you did this, the reaction was that, and then putting that all together develops a pattern. This pattern will be used by the machine again in drilling or in other investigations in the oil well.
Excellent. We have two more questions for the curriculums and also advices for the young graduates. So the first one is that what do you recommend as a major selection for fresh college students?
Well, I'm not going to push people to learn AI. No, it's going to be in every type of life, in every specialty in the future. But what I'm recommending is people should learn about it, should take some courses about it, should know little about it, to the point that when the transition is made, then they are knowledgeable, whether they're doctors or whether they're engineers or whatever. So everybody should start educating themselves about artificial intelligence, because it's going to be like computers. And if you're in my age, you will remember when time with people with no computers, no mobiles, no color TV. And the transition is made in a person's time, a person lifetime. So another transition, a faster, much faster transition will be made for the artificial intelligence. So no matter what your specialty is, you must be educated with artificial intelligence and robotics.
Excellent. The last question we're going to merge a couple of two questions here together, is that how do you think young students can be prepared for that? And also, will the AI will be introduced to the high school students in Saudi or not? Based on your best knowledge.
Well, I see Saudi Arabia is going very fast in this field, and they started the Society for the Artificial Intelligence and Data Society or organization, and they started many things in that field. Though this field is very new, and there isn't a lot of experts in the field. We are going to develop the experts. We in our Robot Academy, we're developing younger kids, younger boys and girls to on programming the robots and understanding the artificial intelligence. I invite everybody to visit the Robot Academy to see what we're preparing for the future. So you're all welcome to the Robot Academy. We have now in Khubar, and we have in Riyadh. In the near future, we'll have one in Jeddah.
Thank you very much, Professor Almuhaidib. It was an excellent presentation with excellent Q&A session. And we'd like to thank you for your contribution and informative session. It was our pleasure to have you with us, and we thank you for sharing with us your valuable time and experience. Ladies and gentlemen, we'd like to thank you all for joining us this evening. Thank you and have a good night.
Thank you very much. Thank you, everybody.